Okay, so we'll move to the next part of the lesson. So we will discuss now about outliers. Okay, so what are outliers? An outlier is an extreme value that lies outside the overall pattern of the data. I think we discussed something similar to this in the previous chapter, isn't it? Do you recall these outliers are what we also call as extreme values? And if you recall, in the previous chapter, we were talking about measures of location, mean, median, mode. And if you and you need to remember that these outliers made an impact on the mean, not on the median. Okay, so these are things that you learned in chapter 2. Okay, so what's an outlier? An outlier is an extreme value that lies outside the overall pattern of the data. So normally, where do you expect in a data set? Where do you expect to find the outliers? Do you expect the outliers to be in the middle of the data set? Now, data set means we arrange the data in order, ascending order. The outlier is going to be either at the beginning or at the very end. You have the outlier either at the very beginning or at the very end because it will be something that lies outside the pattern of the data. Okay, so they say here, now over here, they are giving you the boundary to actually identify outliers, because when you see a data set, how do you actually say that this particular value is an outlier? It might look slightly outside, but how do we, like, do we have a specific value where we say, okay, this value, anything above this value is an outlier, or anything below this particular value is an outlier? So if we have a kind of like a boundary value, it makes things easier for us, isn't it? So what we do now in this part of the lesson is we actually define a boundary value. Okay, so what they say here is a common definition of an outlier is any value that is either greater than, look at this, Q3. Who is Q3? Q3 is the third quartile, upper quartile. Okay, so you recall the upper quartile plus K times Q3 minus Q1. Who is Q3 minus Q1? Q3 minus Q1 is the interquartile range. Okay, so a common definition of an outlier is any value that is either greater than Q3 plus K times Q3 minus Q1 or less than Q1. Less than means what? It's if less than Q1. Q1 means the lower quartile, the first quartile, minus K times Q3 minus Q1. Can you see what's going on here? They are giving you two boundary values to identify outliers. What are they? So any value that is exceeding upper quartile plus K times interquartile range is going to be an outlier, or any value who is smaller than the first quartile minus K times interquartile range is also going to be an outlier. So actually they are giving you the boundaries. So in the exam, you will be told which method to use to identify outliers in datasets, including the value of K. Do you get it? So in the exam, the K value will be given to you. Whether K is 1 or half or 2, it will be given to you. Do you get it? So all you need to do is to apply these values and get the boundaries for the outliers and see whether any data value is exceeding those limits, whether they are outside these limits. Do you get it? So the data points are going to be in between these two. Are you with me? So if this is the data set, just to give you a brief idea. So the lower boundary is Q1 minus K times Q3 minus Q1 is actually interquartile range, right? And the other boundaries Q3 plus K times Q3 minus Q1. Can you see? So if there's any data point who comes outside, now this is a value, right? So if there's any data who is bigger than this value, any data point that comes over here, it becomes an outlier. Can you see? So this region, this is the outlier region. Can you see? So over here, this area is the outlier region. So which means what? Your data values should lie in between these two. The data values that belong to the data set will lie between these two. Is that clear? Okay, so now we'll actually go for the sums. Okay, so we'll move to exercise 3B, question number 1. some data are collected. The Q1 value is 46, the lower quartile, and the upper quartile is 68. A value greater than Q3 plus 1.5 into Q3 minus Q1 or less than Q1 minus 1.5 into Q3 minus Q1 is defined as an outlier. Can you see? The K value is given here very clearly. K value is 1.5. Okay. So they have set the limits. So what's the upper boundary? What's the upper boundary for the outlier? Q3 plus 1.5 into Q3 minus Q1. What is it? Q3 is 68 plus 1.5 into Q3 is 68 minus Q1 is 46. How much is it? How much is it? $68 plus 1.5 into 68 minus 46. How much is it? 101. So upper boundary is 101. And what's the lower boundary for the outliers? Q1 minus 1.5 into Q3 minus Q1. Q1 is 46 minus 1.5 into Q3 minus Q1. Q3 is 68 minus Q1 is 46. How much is it? 13. So can you see? So your data values are all the data values that belong to the data set should be between 13 and 101. So anything that is outside these two limits will become an outlier. So if you check the value 7, is 7 an outlier? What's the lowest value you tolerate? The lowest value, the lower boundary is 13. Anything below 13 is an outlier, and anything above 101 is an outlier. Guys, do you understand? 13 is the lower fence, 101 is the upper fence. Anything in between is okay. Do you get it? Anything in between is okay. But if you go to the behind, that's the outlier region. Can you understand? Okay, so part A, what's the value? 7. 7 is an outlier. Part B, what about 88? 88 is in between 13 and 100. It's part of the data set. So 88 is not an outlier. And what about part C? 105? It's more than 101, which means 105 is an outlier. Okay.